Okie dokie. All right, 8-4, day 1. I'm going to take you through kind of an overview of the rest of the chapter. We skipped section 3, which was on inverse matrices. So no worries about section 3. Section 4 introduces a concept called a determinant. Okay, so here's our plan of action with them. We have 2 sections to go. In section 4, all we're going to focus on is how do we find them. Okay, how do we find them? And then section 5, we'll get into more what is a determinant and what do we do with them. Okay, but finding them can be a little bit tedious, so I don't want you to be thinking about anything other than how do we do this. Okay, if we have a certain type of matrix, we can find a determinant. You know, let's look at how it's done. Now today I'm really going to show you what you're going to eventually call the good case. How to find a determinant of a 2x2. And here's the definition for it. It's not really all that bad. Okay? Just a heads up, for the second day, we go to a 3x3. And that's something that I will expect that you can do, is to do a 3x3. It's a little bit more work than a 2x2, but we'll get to that case in the second day. Notation-wise, keep in mind these 2 things right here mean the exact same thing, whether you have like an absolute value sign around the matrix, or if you just say DET, which is short for determinant. You basically take those numbers diagonally, okay, and then subtract the product of those 2 numbers diagonally. Okay. For a 2x2, it's pretty simple. It's a little bit of multiplication and subtraction. I hadn't mentioned yet, but it's worth noting, determinants can only be done if you have a square matrix. So the number of rows have to be the same as the number of columns. So let's go down here and do a couple. Okay. So based on our definition, we would start in the top left and go bottom right. So we take 2 times 2 minus 1 times negative 3. And that would basically be 4 plus 3, which is 7. Okay? Something to make note of there. Just a few general observations, I guess, about determinants. They're a number. Okay? That's significant. So when we're referring to the determinant of a matrix, it has a single numerical value in terms of what we're after. There's 2 times 2 minus 1 times 4. All right, again, as we expected, we get a number answer, but the other thing to make note of here is apparently a determinant can be 0. That's possible. One thing I'm doing here that I shouldn't, hopefully I can go back and erase these. I'm going to do a picky little notation thing and get rid of those. I really shouldn't have equal signs because those are set equal to a matrix. And what I should have notation-wise, if I want to set this equal to something, I should have set out here. Right? This isn't, 7 isn't matrix A. 7 is matrix A's determinant. So I should do a better job with that, as should you. Okay, that's why I'm making note of it now, that don't get caught up with kind of an endless string of equal signs. Okay, because the determinant of our 2x2 matrix is not the same as the matrix itself. I'll do this one properly from the get-go. All right, so now I'm talking about the determinant of C, which would be 0 times 4 minus 3 over 2 times 2. And there we go. So one other thing to see there, determinants can be negative numbers. They can be positive, they can be 0, they can be negative. So I'm jumping up to the 3 by 3 because honest to goodness, what you saw there in the 2 by 2, that's all there is to it, right? You'll like the 2 by 2 case. It's pretty quick, it's pretty simple. There's a little more to a 3 by 3. So here's what happens. We have to find these things called minors, and we need 3 of them. Okay, and essentially what they are is if you were to delete a row or a column. Okay, let's say I'm going to get rid of row 1, column 1. I'm looking at the matrix that's left over when I do that. Okay, notice I have a 2 by 2. All right. These are a big part of getting a determinant of a 3 by 3. We use their notation like that. So that's minor 1, 1. So that's the one I had drawn in. Then I'm going to take out row 1, column 1, and I would have negative 1 times 1 plus 0 times 2, which would be negative 1. Okay? Next, I'm going to go get minor 1, 2. Okay, now see, I don't want to write it in because I just have to erase it again to do 1, 3. But see if you can kind of visualize what 4 numbers that I'm going to work with. If I take out row 1 and then I take out column 2. This can be the trickiest one because I'm skipping over that middle column. So I have 3 times 1 minus 4 times 2. And we get negative 5. And lastly, I need to do minor 1, 3, which would be 3 times 0 minus 4 times negative 1, which would be 4. Okay? So anytime, and that, I mean, doesn't get us to our final answer, and actually in this lesson we're not going to. I'm not going to take you all the way to the point where we get the determinant of a 3 by 3, but that's part of what we need to do. Okay, so this is probably I don't know, it's kind of the goofiest little part of getting the determinant of a 3 by 3. We have these things called cofactors, okay? And basically what it does is, like, the minors that we found are a big part of the calculation of the determinant. They're like half of it. But so we want those numbers, but we may want to change the sign, and it depends. Different size matrices have different patterns for cofactors, right? The only 2 that you would ever need to know are the 3 by 3 and the 4 by 4. Okay, so I'll show you the pattern for 3 by 3. Looks like this: plus minus plus, minus plus minus, plus, minus, and plus. Okay? As long as we stick to row 1, and I highly recommend that you do, okay, here's what it means. Minor 1, 1, don't do anything to it. Okay? Leave it as the same sign. Notice in row 1, column 2, I have that negative sign. So for minor 1, 2, that was the second one that we found. This tells us we need to switch the sign of that minor. And then 1, 3, go ahead and leave it as the same sign. Okay? All it really means and this is, if you're doing a 3 by 3, it's a given. Minor 1, 2. Okay, and on the one we did, we got negative 5. When I go to use that number in the calculation for our determinant, I need to use positive 5 and change the sign, not negative 5. Okay? We'll call it there. That's how far I wanted to get us to, is through the cofactors. What's to come in day 2 with the 3 by 3 is to show you the formal definition, and then go ahead and do a determinant for a 3 by 3 from start to finish.